So hey guys, starting with chapter 4, which is nothing but CS1 chapter 1, part 2. So what was did in part 1? Basically, we saw four distributions in part 1, which were nothing but discrete uniform distribution. We saw its mean and variance. Then for a Bernoulli distribution, we saw its mean and variance. For the binomial distribution, we saw its mean and variance, and similarly for Poisson distribution, we also saw its mean and variance. So these four distributions, that is nothing but, let me just write it down. Yeah, which is discrete uniform distribution, then Bernoulli distribution, binomial distribution, and the final is Poisson distribution. These four distributions are basically discrete distribution. So what do you mean by discrete? It is nothing but for these four distribution we are going to model as per the required time. So basically we are going to model at the end of 1 week, or you can say 1 day, 1 month, 1 year. So we're gonna model at the end of each day or month or hour or minute. But from part 2, whatever distributions which we are gonna see is basically as per the continuous form. So assume that in discrete we model 1 day. So in continuous we model till time t only. We do not model this aspect at all. But for the discrete one, we are going to model till time 1 at the end of the day. There is nothing to stop in between. But since we have the liberty to stop in between the time period, therefore I can say continuous is in the better form. Discrete we have to model at the end of every day. So let us consider the share price. So suppose this is the share price of Reliance. This is the graph of the share price of Reliance after 1 day. This would give me the value of this only, the discrete format. But the continuous aspect would help me to study each and every point till time t. That is till 1 day. So basically, I get to study each and every aspect rather than an end point. So basically, I can say that continuous is better than discrete. So there are a large number of distributions for uh, continuous. Starting with it, the first distribution is nothing but continuous uniform distribution. What would be its notations, that how it could be derived? It is nothing but x follows uniform with parameter a comma b. If you see part 1, we also had a discrete distribution, but it was denoted by only one parameter, that is nothing but k. Here there are two parameters which denotes the minimum value as well as the maximum value. Okay, so basically here x is my random variable, then a is my minimum value for the random variable or any experiment we do. So a would be my minimum value. Similarly, b would be my maximum value here. Okay. So how does my graph looks? So basically, my graph of uniform distribution, this is x and this is f of x. Okay, so basically my graph would be a constant one. So it would be somehow this for the values of a and b. So the probability values would exactly be same for each part, Consider this part, the probability would exactly be the same. Consider this part, the probability would exactly be the same. So basically my probability would exactly be the same. This is what the word uniform suggests. Uniform suggests that it is same, something is same. What something? Something is nothing but my probability. Okay, this is what my graph of the uniform distribution would look like. Now I will write my PDF. So f of x denotes my PDF, which is nothing but 1 upon b minus a for the values between a to b. Okay. As you can see, this point, the middle point would be my mean. It would even be my median, but it won't be my mode. Mode is same for each and every aspect, right? Therefore, there is no mode for uniform distribution at all. Okay. So yeah. So basically, if I were to derive this f of x, I could derive it as this one. So basically, using the uniform part, so basically a to b, the range of this, the minimum value is a, maximum value is b, f of x dx is equal to 1. Okay, this is how I derive. My f of x would follow a uniform distribution. So basically the each value is a constant value. So I can say that a to b 1 dx would be nothing but b minus a is equal to 1. So I get my answer of 1 upon b minus a. This is my f of x. Okay, let me write it in a proper way. So I'm taking f of x out because we want f of x, we do not know. What is the integration of 1? Integration of 1 would be nothing but t. Integration from a to b. It would be x because we are integrating with respect to x. So a to b is equal to 1. Okay, so I get my answer as b minus a. First value minus second value. So b minus a is equal to 1. I'm taking this part here. So basically my multiplicative part becomes the division part. So I can say my f of x is equal to 1 upon b minus a. This derivation is not at all important. This is just for you all to understand how this came into existence. But yeah, it's okay. Let me just rub this out because this is not at all important and it is not even asked in the examination. What is important is basically to find CDF. Okay, CDF. So I want to find CDF till value of x. So I want to find CDF till value of x. I can write in this way. So my maximum value would be x, but my minimum value is nothing but a. As you can say, I stated my a is the minimum value. Therefore, a would be my minimum value. F of x dx. Okay, what is f of x? F of x is nothing but 1 upon b minus a. So let's substitute that. A x 1 upon b minus a dx. I can take b minus a common because it does not have the x term, because since we are integrating with x term, we require an x term. Since it does not have an x term, it is considered to be a constant. I can take this part basically out. So I'm left with 1 upon b minus a integration of a to x 1 dx. Integration of 1 with respect to x is nothing but x from value of a to x. Therefore, I'm left with 1 upon b minus a. The first value, that is nothing but x minus a. So x minus a upon b minus a. That is what is the derivation of CDF. Whatever derivation I did in the discrete part and the continuous part, you need to like learn that thing, because it is important for you all to understand each and every step I do. In order to understand each and every step, you need to remember each and every step. It's important to learn. So I hope you would be learning from time to time. Okay, now basically this gives me my CDF. If I want to find my median, median would be nothing but f of m. M is my median point. So instead of x, I will substitute m in this formula. I will get m minus a upon b minus a. Okay. My median, what does my median denotes? Median is exactly the middle point. So basically my median would be nothing but 0.5. Therefore I can say m minus a upon b minus a is equal to 0.5. So I'm taking b minus a on this side. So I'm left with m minus a is equal to 0.5 b minus a, or I can write instead 0.5. I'm writing 1 by 2. What did I do? I took b minus a on this side, and basically the division sign becomes the multiplicative sign, and I wrote 0.5 as 1 by 2. That's basic. So I'm taking 2 on this side. So basically I'm left with 2 m minus a is equal to b minus a. Similarly, solving is 2m minus 2a is equal to b minus a. So if I take a this side, I'm left with 2m plus a is equal to b. If I take a on this side, the positive sign becomes the subtractive sign. So 2m is nothing but b minus a, and m is nothing but b minus a divided by 2. This is the formula for median, right? I got the formula for median. Oh, sorry. This would be minus a, this would be plus, and this would be plus. Yeah. This is the formula for median, right? I stated above that my median is equal to mean. So basically, median is equal to mean. Therefore, I can say that mean is equal to b plus a divided by 2. Whatever derivation we will be doing, it is important for you all to learn, as I said earlier. But the derivation that would be asked in the questions are hardly of around 2 to 5 marks. So basically the weightage is less, but these derivation would provide a base for the future chapters. So I want you all to learn each and every derivation, remember each and every derivation. It would be easier for you to apply in the examination if some question comes. Okay. So I got this formula b plus a. Now I can prove that median is equal to mean by using another formula for mean. Which formula did we use basically in for the first part? It was nothing but x into f of x, or you can say p of x, summed over all values a to b dx. Why did we use integration? Integration is used for the continuous term. Since we are modeling continuous distribution, therefore we will be using integration. And sum is used for discrete case. The discrete case was done in the first part, so basically all the discrete part are over. We will be only looking at the continuous aspect, so I'm using integration. And another point, p of x was PDF in discrete. Therefore, if you see the previous lectures, all my answers would be related to p of x. But from now on, it would be related to f of x because it denotes PDF in continuous form. Since we are modeling continuous distribution, therefore we will always be using f of x now. Okay, so yeah, x into f of x dx. So what is the value of f of x? It is nothing but b minus a. Let's see, I have written it right here, b minus a. So I got this value. My b minus a is a constant because it does not have an x term. So basically I can take it out. I can take this part out. So I can write this as nothing but 1 upon b minus a integration of a to b x dx. Right? Solving the integration part now, I would get my answer as x square by 2 a to b. Why? Integration of x dx is nothing but x square by 2. Why? X raised to n integration is nothing but x raised to n plus 1 upon n plus 1. Right? So what is n here? N here is nothing but 1. So if I substitute the value of 1 here, I get x square by 2, which is nothing but this. So this is the formula. If you do not remember, just note it down. If you do remember, then go ahead and solve. It would be basic for you. So yeah, let me write it further. Let me substitute the value of b and a. So I get 1 upon b minus a, b square minus a square, right? I can write the formula of a square minus b square as nothing but a minus b into a plus b. This was basic maths, what you did in the 10th and the 12th standards. So I'm writing here. It would give me my answer as 1 into b minus a into b plus a, right? So b minus a gets cancelled. I'm left with b plus a divided by 2. If you see this answer, b plus a divided by 2 and b plus a divided by 2, it's exactly the same. So you use any formula, the formula of median or mean, to get expectation of x. It would be okay for you. Okay. So the final would be nothing but my expectation of x square. How is expectation of x square? It is x square PDF, right? And summed over all values. Here it would be integration because it is a continuous distribution. My minimum and the maximum range is a and b. So let's substitute the value of f of x first. So x square upon b minus a dx. Since b minus a is a constant, I can take it out. This is a constant, I can take it out. So I'm left with 1 upon b minus a integration of a to b x square dx, right? What was the formula of integration? It was nothing but x raised to n dx is x raised to n plus 1 upon n plus 1, right? So here n is 2. So x square dx would be nothing but, instead of n I will write 2. So 2 plus 1, which is nothing but 3 upon n plus 1, that is 2 plus 1 is 3. So I'm substituting this value here. I get 1 upon b minus a x cube by 3 a to b. Similarly, writing this, I get 1 upon b minus a into b cube minus a cube upon 3, right? There was one formula with respect to a cube minus b cube, if you remember. It was nothing but a minus b into a square plus ab plus b square. If you have done, if you do not remember, just learn this formula. This formula was done in your 12th standard HSC or something. So applying this formula, so it would be nothing but 1 upon b minus a into b minus a b square plus ab plus a square, right, upon 3. This and this gets cancelled. So I'm left with b square plus ab plus a square upon 3. If you are getting confused, what did I do in both the step? Basically, I compared this and this. Here A is B and B is A. So it's just reciprocal. So here it would be B minus A. It would be B square plus BA plus A square. It's just like I made a comparison and then I just wrote a formula. So it's nothing great. I use the same formula only. Okay, I got expectation of x square. I have expectation of x. I can find my variance. So what is the formula for variance? Variance is nothing but expectation of x square minus expectation of x the whole square, right? So what is my expectation of x square? It is nothing but b square plus ab plus a square divided by 3. What is expectation of x? I got b plus a upon 2. So expectation of x is b plus a divided by 2. I want it square, so square. Let's solve ahead. Yeah, upon 3 minus b plus a the whole square. I'm just taking out the square, so basically a by, not, let me write m by n. The whole square is nothing but m square by n square. So m square is nothing but b plus a the whole square upon 2 square, that is nothing but n square. So let me simplify this. I get b square plus ab plus a square upon 3 minus b plus a square. I can use the formula of a plus b square, normal formula, which was nothing but a square plus 2ab plus b square. So let me write that formula. I will get b square plus 2ab plus a square divided by 4. 2 square is 4. So yeah, let me simplify it. I will take the denominator constant. How can I take the denominator constant? I multiply the first term with respect to 4 and the second term with respect to 3. I get 4 into b square plus ab plus a square minus 3 into b square plus 2ab plus a square, right? Divided by 4 into 3, which is nothing but 12. So 12. Let's just simplify it and get our answer. It would be nothing but 4b square plus 4ab plus 4a square minus 3b square minus 6ab minus 3a square. So basically I take each term and find my answer. So 4a square minus 3a square, I am left with a square. Similarly 4ab minus 6ab, I am left with 2ab, and the final term 4b square minus 3b square, I am left with plus b square divided by 12. If you see, this is nothing but my formula for a minus b the whole square, right? So I can write the above as a minus b the whole square upon 12. So this is my formula, okay, for the variance aspect. Let's do one sum so you'll get to know about each and every aspect. Starting with it. So suppose I have a random variable y which follows continuous uniform distribution with 50 and 150. So basically, how did I denote my continuous uniform distribution? I denoted as this one, right? So if I compare these, I get A is equal to 50 and B is equal to 150, right? So suppose now I have to find probability of Y less than 75. How will I do? Less than 75, so my maximum value would be 75, but my minimum value would be 50 for the uniform distribution f of x dx. What would be my f of x? F of x formula was nothing but 1 upon b minus a. Here b is 150 minus a is 50. So it is nothing but 1 by 100. Okay, so 50 to 75. F of x is 1 by 100 dx. Similarly, I take my constant out. Okay, I am left with integration of 50 to 75. 1 by 100 is taken out. 1 into dx. Integration of 1 is nothing but x. So 1 by 100. 50 to 75. Sorry, guys. 50 to 75. So I'm left with 1 by 100. The uppermost value, that is 75, minus the lower value, which is 50. I'm left with 25 by 100, which is nothing but 1 by 4. So the probability that y is less than 75 is 1 by 4. Okay. So suppose now I want to find probability that my y lies between 120 and 50. How do I do? It is nothing but a change in integration value. So my maximum value would be 120, minimum would be 50. What is my f of x? It is 1 by 100. So let me just write that 1 by 100. Let me take the common out, which is 1 by 100. Integration of 50 to 120 x dx. Sorry, 1 dx. Integration of 1 is x. So 1 by 100 x 50 to 100. How do I get these value? It is nothing but upper value minus lower value. So 120 minus lower value is 50. So I get my answer as 1 by 100 into 70, which is nothing but 7 by 10. So the probability that y lies between 50 to 120 is 70%. Or I can say 7 by 10. It's one and the same. This is how the sum would be given. Guys, any, you can say, like if you even solve the revision notes, none of the derivation has ever been asked in the examination, though I said to be on the safer side that derivation could be asked relating to 2-4 marks. So it is not necessary for you all to know the derivation, but I want you all to learn the derivation because it would be important in the future. That's the main reason. And it would help you to give the base with respect to the derivation of each aspect. We just require the formula. The formula is directly given in the tables book. So if sum comes relating to expectation of x, you do not have to prove anything. You just have to use this formula. For example, this formula directly, which is given in the tables book. You have to see that formula and basically use the value of b and a and get one answer. That's it. You do not have to do any work. See the formula from your tables book. See the value of b and a, substitute the value and get the answer. That's it. You do not have to derive anything. However, I have given you the derivation for your understanding, and even I want you all to remember the derivation. So please remember the derivation. It would be really helpful to pass CS1. Okay, so I'm done with the uniform distribution case. Next case would be exponential distribution. There are about 18 distribution, guys. It would be a big chapter. So please bear with us. Okay. So thanks a lot.